Problem 1. A post is supported by two wires, one on each side in opposite directions. So I have the ground, and I have this post that's supported by two wires, one on each side going in opposite directions. So I have a wire going this way, and I have a wire going this way. And it says these two wires create an angle of 80 degrees. So basically I have an 80-degree angle right there. The ends of the wires are 12 meters apart on the ground. So I know this distance on the bottom is going to be 12. And it says with one wire forming a 40-degree angle with the ground. So it doesn't really matter which wire you choose, so maybe I'll let this wire here forms a 40-degree angle with the ground. Find the lengths of the wires. So here I'm going to have to find the length of this left wire and the length of this right wire. And in order to go about doing that, I'm going to start off with X. And X, this wire, is in two different triangles. It's in the right triangle, and it's also in this big triangle. And I have to try to figure out which of the two triangles I want to use to solve for X. If I look at the smaller triangle, I definitely have an angle. I have a 40-degree angle. I know this entire ground is length 12, so that doesn't tell me the bottom side. The entire bottom is 12. I know this whole angle is 40, but that whole angle is 80, but I don't know that like this is going to be 40 and this is going to be 40. So I don't have enough information just to use this right triangle. Instead, I'm going to try to use that big green triangle where I have X on the left, Y on the right. I have this whole angle up there is 80. I know this angle here is 40. And this entire ground is going to be 12. So I'm going to use that green triangle to solve for X. First I'll look to use SOHCAHTOA. I'll look to see if there's a 90-degree angle. I have two of the angles, so I can add up the 80 and the 40 and then subtract that from 180. So it looks like here this missing bottom angle is going to be 60. So I don't have a right angle, so I'm not going to be using SOHCAHTOA. Next, I'll look to use the law of sines. In order to use the law of sines, I need to be given a matching set of side angles. And here, if I put some letters down so we can communicate, it looks like I do have a matching set. It looks like I have angle A and I have this side A. So here, since I have a matching set, my A's, I'm going to use the law of sines. And I'm first trying to solve for X. So that's going to be side C. So I'm going to go little c over the sine of angle C. And that equals my matching set, little a over the sine of angle A. Here I'm going to have little c, which is X, over the sine of angle C. So that's going to be the sine of 60. That equals little a, which is 12 over the sine of angle A, so that's going to be the sine of 80. And here this is a law of sines, so I'm going to cross multiply. So here I'm going to have the sine of 80, and that equals 12 times the sine of 60. So if I want to figure out the length of that left-hand wire, I'm going to divide both sides by the sine of 80. So here, X is going to be equal to 12 times the sine of 60 divided by the sine of 80. So here X, that wire is going to be 10.6. 10.6. And since I have that matching set, I'm also going to be using the law of sines to find little y, which is the side opposite B. So I'm going to be going either the law of sines, I can go the sine of B on the bottom, little b up top, so I'm trying to solve for y. That equals sine of A on the bottom and little a up top. That's my matching set. So here I'm going to have y, that's B, over the sine of 40. That equals little a, which is 12 over the sine of 80. So here I can cross multiply y times the sine of 80. That equals 12 times the sine of 40. And here to go about solving for y, I can divide both sides by the sine of 80. So one way to figure out what y is I can go 12 times the sine of 40 and divide that by the sine of 80. Another way I could have found y, since now I have all this information, is I can go about using the law of cosines. Because I'm trying to find side B. So I could have gone b squared equals a squared plus c squared minus 2ac times the cosine of b. Because another checklist in terms of which rule you're allowed to use, if you have two sides, here I have now side x is 10.6. If I have two sides, 10.6 and 12, and the angle in between, which I do, is 40. So that's why I can also go about solving by using the law of cosines. I could have done b squared equals a squared, which is 12 squared, plus c squared, which I found was 10.6 squared, minus 2 times a, which is 12, times c, which is 10.6, times the cosine of angle b, which was 40. Remember, if you're using the law of cosines, that whatever side you're finding, that's the opposite angle that you're using to solve. So here I could have either done this expression up top, 12 times the sine of 40 over the sine of 80, or I could have evaluated this expression and then taken the square root of that. So here if you use the law of sines, your answer would have been 7.8. And here if you use the law of cosines, your answer would have also been 7.8. Sometimes you might get a slightly different answer, maybe a tenth or two different, but here the other wire y, is 7.8. Problem 2, two ships are sailing from Halifax. So here I'll put Halifax in the middle. And it says the Nina is sailing due east. So here's our directions map, north, south, east, and west. So east is to the right. So the Nina is sailing to the right. And it says the Pinta is sailing 43 south of east. So if this is east, we need to go south. We need to go down of east. So basically, this is the direction in which the Pinta is sailing. So my Pinta is going to be sailing this way, and it's 43 degrees south of east. So that angle is 43. After an hour, the Nina has traveled 115. So the Nina has gone 115, and the Pinta has gone 98. How far apart are the two ships? Well, the Nina and the Pinta, right, the Santa Maria I guess will be going later. This is the distance that you have to find. How far apart are the two ships? So if I go through my checklist, SOHCAHTOA, do I have a 90-degree angle? No, I have a 43-degree angle. Law of sines, do I have a matching set given to me? The answer is no. Here I have angle H, and I'm trying to find side H. Here I have side N, but I don't have angle N. And here I have side P, but I don't have angle P. So there's no matching set. So SOHCAHTOA is gone, no 90 degrees. Law of sines is gone, no matching set. This one here is going to be an example of the law of cosines because you're given two sides and the angle in between. So here I'm trying to find side H. So I'm going to write H squared equals N squared plus P squared minus 2NP times the cosine of H. Again, make sure this angle matches that side. So here we're going to have h squared equals n squared, so that's going to be 98 squared, plus p squared, that's going to be 115 squared, minus 2 times n times p, so 2 times 98 times 115, times the cosine of angle h, here the cosine of 43. So this was the only rule that you could have used to answer this one. Here you're using the law of cosines by entering in this entire side on your calculator and then taking the square root. So here the two ships are 79.7 kilometers apart. Times. Three friends are camping in the woods, Bert, Ernie, and Elmo. They each have their own tent, and the tents are set up in a triangle. So this one is hopefully pretty straightforward as far as the diagram. It doesn't matter where you label each person as long as everything is labeled clearly. Bert and Ernie are 10 meters apart. So Bert, Ernie, 10 meters apart. The angle formed at Bert is 30, and the angle formed at Elmo is 105. How far apart are Ernie and Elmo? So here we're trying to find x. So what I'm going to do is go through now my checklist. First, I'm going to look to use SOHCAHTOA to see if I have a 90-degree angle. Here I have a 30-degree angle and a 105-degree angle. So if I add those up and subtract it from 180, it looks like the missing angle here is going to be 45 degrees. So that's the angle by Ernie. Next, we'll look to use the law of sines. No right angle, so now we'll look to use the law of sines. And here I think that's what we're going for, because here we have the matching set of 10 and the 105 degrees. Now I already have letter B, but I have two letter E's for these names. So maybe I'll call this point B, I'll call this point C, I'll call Elmo point A, just so I can kind of communicate. And here I'm trying to find X, which is little b. Here my matching set are my A's. So I'm going to write little b over the sine of angle B. That equals now my matching set, little a over the sine of angle A. Again, the letters don't matter, they just matter in order for you to stay organized. So here I'm going to have little b, that's x, over the sine of angle B, so that's the sine of 30. That equals little a, so that's the side opposite angle A, so that's 10, over the sine of angle A, here the sine of 105. So I'm going to cross multiply since I'm using the law of sines. I have x times the sine of 105. That equals 10 times the sine of 30. And now to solve for x, I'm going to divide both sides by the sine of 105. So to figure out how far those two gentlemen are apart, I'm going to, on my calculator, do 10 times the sine of 30 and then divide that by the sine of 105. So here the distance between these two gentlemen, 5.2.